Choosing the right web development tools is essential to your success as a web developer. In this course, you'll learn why Fiddler is one of the best tools for web debugging. Now, before diving into Fiddler, let's take a step back and talk about web debugging. In short, web debugging is the process of finding and diagnosing errors in web applications. Just like with any other type of software, errors can creep into web applications. Some errors are due to bugs in the code, while others are caused by an incorrect configuration or bad data. No matter what the cause, it's important to be able to find and fix errors quickly. So, why do we treat web debugging as a separate category? The main reason is that the web is a unique environment with its own set of challenges. To understand why, let's take a look at how web applications work. Unlike desktop applications that run locally on your computer, web applications are distributed. This means that the code for a web application is running on a server somewhere, and the user is interacting with it through a web browser. The user-facing part of a web application is called the front end, while the code running on the server is referred to as the back end. These two components communicate with each other over the network. So, web applications require an active internet connection to function. When you enter a URL into your web browser, the browser sends an HTTPS request to the server. The server then processes the request and sends back a response. The response includes the front-end code of the web application. The browser then interprets this code and renders the web page to the user. Most web browsers let us inspect the page's source code. This is the code that was sent back from the server in response. You will notice that it's a mix of HTML, CSS, and JavaScript code. Without going into too much detail, HTML is used to structure the content of a web page, CSS is responsible for its styles, such as colors and fonts, and JavaScript makes it interactive. The backend of a web application is developed using a server-side programming language like PHP, Ruby, Java, .NET, or Python. JavaScript has gained popularity in recent years as a backend language with the help of frameworks such as Node.js. The code for the backend is typically not visible to the user. In this course, we'll focus on the front end, but it's important to be aware of both sides of web applications. So that's a brief overview of how web applications work. Now let's talk about some of the challenges that come with debugging them. We've seen that web applications are distributed systems that communicate over the network. This architecture introduces a few challenges that can make debugging more difficult. First of all, there are more moving parts in a web application than in a desktop application. There's the web browser, the server, and potentially other services that the application is using, such as a database. This means that when something goes wrong, there can be multiple places to look for the cause of the problem. Another challenge is that we can't just launch a web application on our local machine and start debugging it. We need to have a server set up and running before we can even start. Yet another issue that can make debugging web applications more difficult is that an active connection with the server is required. Latencies and network errors can introduce unpredictable issues that are hard to reproduce. Plus, we can't use a traditional debugger because web applications are accessed through a web browser. Debuggers are tools that let us step through our code line by line and inspect the values of variables. They are very useful for finding bugs, but desktop debuggers don't work with web applications. Finally, I'd like to mention that network requests are asynchronous by nature. What does this mean? After firing off a request, our code will continue to run and might even make more requests before the first one finishes. For example, let's say we have a web page that displays images. Each image gets fetched from the server as a separate network request. Once a request is sent, the client code that initiated it will move on without waiting for a response. It will execute the next line of code and fire more network requests to fetch the remaining images. In the meantime, we can use the page even though some of the images are still being fetched. If these requests were synchronous, the page would be blocked until all the images have been downloaded. Now, while asynchronous requests are great for the user experience, they make debugging more difficult. We need a way to intercept requests and responses so that we can inspect them. And we need to mock server responses so that we can test different scenarios without depending on the network. Fiddler is a tool that lets us do just that. In the upcoming modules, we'll explore Fiddler's key features in more detail. But first, let's take a look at how Fiddler fits into the bigger picture of web development. Fiddler started as Eric Lawrence's side project back in 2003. At the time, he was working as a program manager on the Office clipart team at Microsoft. Originally, Eric developed Fiddler as a tool to help with visualizing the traffic between a client application that communicated to a web server that would deliver clipart. The tool allowed testers and developers to, quoting Eric, fiddle with traffic, and that's how Fiddler got its name. After the launch of the first version of Office Online, serious performance and scalability problems arose. Thus, Eric started adding features to Fiddler that would help detect and diagnose performance issues such as uncompressed resources, inefficient caching, and unnecessary redirects. Later, he added features to test for web security vulnerabilities. As time went on, Fiddler became a more powerful web debugging tool. When Eric later joined the Internet Explorer team, Fiddler quickly became the de facto tool for web debugging. He continued working on Fiddler as a side project until 2012. In September of that year, Telerik acquired Fiddler, and Eric joined the Telerik team to work full-time on his side project turned product. In 2018, Telerik announced Fiddler Everywhere, a cross-platform version of Fiddler that runs on Windows, macOS, and Linux. One of the main reasons Fiddler became so popular is its ease of use. Fiddler has a very intuitive user interface that makes it easy to get started with web debugging. Although other tools have been developed over the years that offer similar features, Fiddler remains the go-to tool for many web developers because of its simplicity. The story behind Fiddler is a great example of how a tool that started as a side project can become essential for an entire industry. Although the original version had the single purpose of debugging clipart, Fiddler has come a long way since then and is now a cross-platform tool used by web developers all over the world. Mobile development is one of the most popular uses for Fiddler. Fiddler can capture traffic from iOS and Android devices. In this video, I'll show you how to capture and analyze traffic from an iPhone. First, we need to make sure that the device is on the same network as the computer running Fiddler. Then, we need to configure the iOS device to use Fiddler as a proxy. On the device, I'll go to Settings, Wi-Fi, and select the network that Fiddler is connected to. Then, I'll tap on the eye icon next to the network name and scroll down to the bottom of the page. Here, you will see a section called Configure Proxy. To configure the proxy, I'll choose Manual. In the Server field, you will need to enter the IP address of the computer running Fiddler. To find out the IP address, you can go to the Fiddler's Connections section located at the bottom right corner of Fiddler Everywhere. And I'll now enter this IP address in the Server field on my iOS device. The next step is to enter the port number. By default, Fiddler uses port number 8866, but you can double check and even change this in Fiddler's settings. I'll click on the Settings button and the port number is listed under the Connections tab. If the Allow Remote Computers to Connect is unchecked, you will need to check it and save the changes, or else Fiddler will not be able to capture traffic from your device. Next, I'll type the port number on my iPhone's proxy configuration page and tap on Save in the upper right corner of the screen. Now that the device is configured to use Fiddler as a proxy, we can start capturing traffic. However, it will only work with non-secure HTTP traffic. To be able to also see secure traffic, we need to trust Fiddler's root certificate on the iOS device. To do this, I'll open the Fiddler root certificate page in Safari on my iPhone. http://ipv4.fiddler:// 8866. For this to work, make sure Fiddler Everywhere has capturing turned on and the Allow Remote Computers to Connect is checked in Fiddler's settings. Otherwise, the page won't load. Once the Fiddler root certificate page loads, I'll tap on the Fiddler root certificate link and click Allow when prompted. I'll choose iPhone as the device to install the certificate, and I'll need to enable it in Settings. I'll now go to Settings, General, and scroll down to VPN and Device Management. To install the Fiddler root certificate, I'll use the Downloaded Profile section and tap the certificate named Do Not Trust Fiddler Root. I'll tap Install and enter my passcode. The final step is to trust the certificate. So I'll go to Settings, General, About, Certificate Trust Settings, and enable full trust for the Do Not Trust Fiddler root certificate. Now that I've added the root certificate, Fiddler will capture and display all traffic from my device, including secured traffic. Okay, now I'll open up Safari on my iPhone and type in pluralsight.com. The live traffic view in Fiddler will now show all the requests and responses made by my device. When you no longer need to capture traffic, you can go back to your device's settings, Wi-Fi page, and remove Fiddler from the proxy configuration. You can remove the profile by going to Settings, General, VPN, and Device Management. That's it. I wanted to show you how versatile Fiddler is by walking you through this particular scenario of capturing traffic from an iOS device. Fiddler is a powerful tool that can be used in a variety of ways to debug web applications.